Hello and welcome back to 5th grade math module 2. I'm Mr. Kissinger. I'm a teacher at the Syracuse Academy of Science and Citizenship in Syracuse, New York. This is the video for module 2, lesson 8. So our objective today is fluently multiply multi-digit whole numbers using the standard algorithm and using estimation to check for reasonableness of the products. So we're going to move away from the area model a little bit, and we're going to start to try to use the standard algorithm, and we're going to use estimation to check to make sure that our final products are close to our estimate. All right, so if we look at the top of our page here, it says estimate the product first. Solve by using the standard algorithm. Use your estimate to check the reasonableness of your product. So we want our final product to look similar to our estimate. In the first, in letter A here, they've already estimated for us, rounded 213 to 200, and we rounded 328 to 300. When you multiply 200 by 300, we get 60,000. So we want our final answer, our product, to be close to 60,000. So what we're going to do is we multiply 213 times 8 times our ones place. So we'll start with our 3 times 8. It's 24. Carry the 2. And then we have 1 times 8, which is 8, plus our 2. So we carry our 1, that's 10. And then 2 times 8 is 16, plus 1 is 17. So we have 1,704. So now we're going to multiply all of our 213, all of our place values in 213 by 2. Except it's not 2, it's 20. So we know that it's going to end in a 0. So we do 3 times 2 is 6. 1 times 2 is 2. And 2 times 2 is 4. 4,260. And then our last place value is our hundredths place. That's a 3. So we're going to multiply 213 by 3, except it's not 3, it's 300. So we're going to add 2 zeros. 3 times 3 is 9. 1 times 3 is 3. And 2 times 3 is 6. So we're going to take all those and add them together, which will give us 4, 6, 9 plus 7 is 16, plus 2 is 18. Carry our 1. 1 plus 3 is 4. And then we bring our 6 down. We have 64,864. And that's our product. Now we want to check to make sure that's close to our estimate. Our estimate was 60,000. Is 64,864 close to 60,000? I would say so. So we're all set with that one. Let's do one more here. We'll go to letter B. 662 times 372. So first let's make an estimate. I would say that 662 is close to 700. So let's call that 700. And then we'll multiply by 372 is close to, we'll call it 400. So 7 times 4 is 28. Add our 4 zeros. So we know our product should be close to 280,000. So let's start with 662 times 372. We'll use our standard algorithm. 2 times 2 is 4. 6 times 2 is 12. Carry our 1. 6 times 2 is 12. But we have to add one more up here. So we get 13. We got 1,324. Now we're going to multiply everything by 7, but it's actually going to be 70. So we have to add a 0. 2 times 7 is 14. Carry our 1. 6 times 7 is 42. 6 times 3 is 18. But we have to add our 4 up here. So we get 22. So our second row is 22,240. And then we have to multiply by 3, but it's actually 300. So then we take 2 times 3 is 6. 6 times 3 is 18. 6 times 3 is 18 again. But we have 1 left, so we do 19. All right. And then we're out of room down here, so what I'm going to do is I'm going to move these up here, and we'll add them together. We'll add all these together. We get 4, 6. 6 plus 2 plus 3 is 11. 12. 8 plus 2 plus 1 plus 1. And then 9 plus 1 is 10, plus 2 is 12. And our total is 222,164. And that should be close to our estimate of 280,000. Not super close, but close enough that we know that we're around the same ballpark here as 280,000. We can assume that our product is correct. All right, now let's try a word problem. So here where it says number 2, it says each container holds 1 liter, 275 milliliters of water. How much water is in 609 identical containers? Find the difference between your estimated product and the precise product. So I know that 1 liter is 1,000 milliliters. So each container, when I add that to 275 milliliters, each container holds 1,275 milliliters. How much water is in 609 identical containers? Well, if I round this to the nearest 1,000, I would say that each one holds about 1 liter or about 1,000 milliliters. Since we know that we're going to be doing our final calculation in milliliters, I'm going to multiply 609 by 1,000. Which is 609,000. So that's going to be our estimate right there. Now let's use the standard algorithm, and we're going to multiply 1,275 by 609. All right, so let's multiply all of our place values by 9 first. So 5 times 9 is 45. Here are 4. 7 times 9 is 63. Plus 4 is 67. 2 times 9 is 18. Plus 6 is 24. And then 2 plus 1, or 1 times 9 is 9. Plus 2 is 11. So our first number is 11,475. Now we can multiply all of these numbers by 0, but we don't need to because we know that the answer is going to be 0. So we're going to skip right to our hundreds place. So now we need to multiply each one of these place values by our hundred place, which is 6. But it's really 600. So we'll add 2 zeros. 5 times 6 is 30. 7 times 6 is 42. Plus 3 is 45. 2 times 6 is 12. Plus 4 is 16. And then 1 times 6 is 6. Plus 1 is 7. So we have 765,000 plus 11,475. We have 5, 7, 4. 1 plus 5 is 6. 1 plus 6 is 7. We have 776,475, excuse me. Is that close to 609,000? I would say pretty close. So what is our question here? It says find the difference between your estimated product and your precise product. So if we had 776, 475 with 609,000. 5, 7, 4, 6 minus 9, we need to borrow. 16 minus 9 is 7. 6 minus 0 is 6. And we are about 167,475 milliliters off, which means we were about 167 liters off. We have to be careful when we look at a word problem. We have to really be sure of what it's asking, because it wasn't asking us for the amount that the containers can hold in total. It was asking us for the difference between our estimated product and the precise product, which is when we actually do the multiplication and find the product. So make sure we're always reading really carefully when we're doing word problems to see what the question is asking. All right, well, that's it for lesson 8 of module 2. You guys have an awesome day, and we will see you next time.